Welcome to my algebra class. We're on Chapter 5, Section 2, Simplifying Fractions with Monomials. This small area right here is your vocabulary that you can copy down on in your vocabulary notebook. The rule that we're going to be using is subtracting exponents when we're dividing powers and canceling. So these examples are like the problems that you're going to be doing on your assignment. So the first one here, we can cancel the 5 goes into 5 once and the 5 goes into 10 twice. We can cancel out an m here and one m here, leaving an m. So we have m over 2. Second example, we can cancel out the x here and the x here, and our answer is 6/7. Example number 3, we can cancel out 7 d's on the bottom and 7 on top, and that would leave us 12 minus 7, 5 d's. So our answer is d to the 5th. The fourth example, we can cancel out 2 c's on top and 2 on the bottom, leaving c to the 9th. So our answer is 1 over c to the 9th. In the fifth example, we have a division problem. And starting with the numbers first, cancel out 5 goes into 15 3 and into 10 twice. We can cancel out 2 m's on top and 2 on the bottom, leaving m to the 6th. Cancel out 3 n's on the bottom and 3 on top, leaving n to the 4th. And the p to the 4th and the p to the 4th cancel out. So what we have left on top is 3 times 1 times n to the 4th times 1, or 3n to the 4th. And on the bottom, 2 times m to the 4th times the 1's. So we have 2m to the 4th on the bottom. We also are going to be doing problems where they start out with a monomial and then they take out a factor of it and they want the other factor to get back to this. So we just basically ask ourselves what we need to do to what's given here to get back to the original monomial. So to get 9 back to 36, we need to multiply by 4. To get x squared back to x to the 4th, we need 2 more x's. All we have to do is subtract the exponents to see what we need. And then here we have y to the 1st. We need y to the 2nd. And you can double check by multiplying. And the last type of problem you're going to be working with is finding the greatest common factor of a pair or more of polynomials or monomials. And you always start with the number part first, and the greatest common factor of 12 and 18, the largest number that goes in is 6. And then when you get to the variable parts, they have to have them in common. They both have m's, and you always choose the smallest power because that's what's shared. So m to the 2nd, and they both have n's, so we can put an n down, and the smallest power is understood here, it's 1. So our answer is 6m squared n. We just don't write the 1. We're ready to do the assignment, so you need your books open to page 192 and your paper headed, folded in half, and your title 192 written 1 to 56. So problem number 2. Use 2 lines for fractions. We have 54 over 72. The largest number I can see that goes in there is a 9, and 9 goes into 54 6. And then 72, 8. However, that wasn't the most, but we can continue simplifying. 2 goes into 6, 3, and into 8, 4. So our answer is 3/4. Problem number 4, we have 10 to the 9th power over 10 to the 7th. We can cancel out 10 7's on the bottom and 10 on top, leaving 10 to the 2nd. So our answer is 10 to the 2nd power, which is equal to 100. Problem number 6, we have 10m over 5m. Starting with the numbers, the coefficients, cancel out the 5 and the 5 and 10. And then we can cancel out m and m, so our final answer is just the 2. Problem number 8, we have 12 times 10 to the 3rd over 4 times 10 to the 4th. Starting with the numbers, 4 goes into 4 once and into 12 3, and then we can do the powers of 10. There are 3 10s here and also 3 down there, so we can cancel out 3 10s, leaving 1 10 on the bottom. So we end up with 3 times 1 on top and 1 times 10 on the bottom, which is 3 tenths. Problem number 10, we have 3n to the 7th over 15n cubed. 3 goes into 3 once and into 15 5, and we could cancel out 3 n's in the bottom and 3 on top, leaving n to the 4th. So multiplying the top, we get n to the 4th, and on the bottom over 5. Problem number 12, 3r squared s over 9rs squared. Starting with the coefficients, 3 goes into 3 once and into 9 3. We have 1 r on the bottom, and we can take out an r on top, so we have an r left. S, we can take out 1 s there, and 1 s here, we have an s in the bottom. So multiplying those on top, we get an r. 1 times r times 1. And on the bottom, 3 times 1 times s is 3s. You might want to start leaving yourself a line up here and a line down here to do your canceling so that you don't get lost. Problem number 14, we have negative 6pq squared over negative 15pq. Negative divided by negative, that's a positive. 3 goes into 6 2, and 3 goes into 15 5. We can cancel out the p's and take out a q on the bottom and a q on top, leaving a q on top. So the top is 2q. Remember, it's positive, and 5 on the bottom. Problem 16, we have 42yz to the 4th over negative 48xz cubed. Our answer is going to be negative, so I'm just going to put that down right now because I have a positive divided by negative. And 6 goes into 42 7, and 6 goes into 48 8. We can cancel out, can't do anything with the y and the x, but we can take out 3 z's on the bottom, 3 z's on the top, leaving a z. So on the top we have negative 7 y z, and on the bottom negative 8 x. Keep the negative sign at the top or in front of the fraction bar. Problem number 18, r squared s to the 4th t over r squared st cubed. We can cancel out the r squares. We can take out 1 s in the bottom and 1 on the top, leaving s cubed. 1 t on the top, 1 t in the bottom, leaving t squared. So on the top we just have the s cubed times the 1's, and on the bottom the 1's times the t squared. So our answer is s cubed t squared. Problem number 20, 39 x cubed y squared z over 52 x squared y. See, 13 is the greatest common factor, goes in there 3 and in here 4. And then I can take out 2 x's on the bottom, 2 on the top, leaving me an x. 1 y on the bottom, 1 y on the top, leaving a y. Can't do anything with the z. So I have 3xyz over 4. Problem number 22, 7m squared over the quantity 7m squared. So before I can cancel, I have to get rid of the parentheses. So I have 7m squared over 7 times 7 is 49m squared. Now I can cancel. 7 goes into 7 once and into 49 7. The m squares cancel out, so I have 1 over 7. Problem 24, the quantity 5a squared taken to the 3rd power over 5a cubed taken to the 2nd. We have to take the power of the product, so the 5 cubed is 125, and multiply my exponents a to the 6. over 5 squared is 25, a to the, multiply your exponent to the 6. 25 goes into 25 once and into 125 5, and the a to the 6 is canceled, so my answer is 5. Problem 26, quantity 3mn squared over 3mn squared. We have to take the product and square it, so 3 squared is 9, m to the first squared is squared, and n squared over 3mn squared. Cancel the 3 and the 9, goes in 3 times. Take out one m here, that leaves me an m here. The n squares cancel. So on top I have 3m, and on the bottom 1, so my answer is just 3m. Problem 28, I have negative a to the 7th power over negative a to the 4th power. And the parentheses are inside. So a negative base to the 7th power is going to be a negative a to the 7th. And a negative base to an even power is going to be positive a to the 4th. I can take out 4 a's in the bottom, 4 on top, leaving me 3. So my answer is negative a to the 3rd power. Problem number 30. I have a negative t to the 4th power taken to the 3rd over negative t to the 2nd power taken to the 5th. Well, negative 1 to the 3rd power is a negative t to the 12th. Multiply your exponents. And negative 1 to the 5th is negative t to the 10th. Negative divided by negative is positive, and I can take out 10 t's in the bottom, 10 on the top, leaving me 2. So my answer is positive t to the 2nd. Now we're moving on to the next type of problem. 32. You have 12w to the 6th, and you want to find the factor, and when you times it by 3w squared, you'll get back 12w to the 6th. Well, 3 times 12, 3 goes into 12 4 times, we need a 4 there. And we have w to the 2nd, and I got to get to w to the 6th, so 6 minus 2, I need a w to the 4th. And there's my answer. 34, I have 18pq cubed. First factor is 6pq. I need to find the second one. 18 goes into, 6 goes into 18, 3. And I have a p and a p here, so I don't need any more. And this is q to the 1st, so taking that away from q to the 3rd, I need a q to the 2nd. 36, negative 28 r to the 4th s cubed. And the factor they have here is negative 7r, so I need to figure out what to multiply it by. Negative 7 goes into negative 28 at positive 4 times. I have r to the 1st, r to the 4th, so subtract, I need r to the 3rd. And I don't have any s's, so I need s cubed. 38, 72 h cubed k. Factor is negative 8 hk. Negative 8 goes into 72, negative 9 times. I have 1 h, subtract that from h cubed, I need h squared. And I have a k and a k, so that's all I need. Problem number 40. 2s cubed t to the taken to the 5th is equal to the factor 2s cubed t taken to the 3rd. And we're trying to find the missing one. This involves some work because we have to take the power of this. So this is going to be 2 to the 5th power, which is 32. S to the 15th, t to the 5th. And this becomes taking everything inside to the 3rd power. 2 to the 3rd power is 8. S to the 9th, multiply your exponents, t to the 3rd. So what we're missing, 8 goes into 32, 4. We have s to the 9th, take that away from s to the 15th, so we need s to the 6th. And we have t to the third, take that away from t to the fifth, we need t to the second. So it's 4s to the sixth, t to the second. Problem number 42. We have 2c cubed d to the second taken to the fifth equals 2c squared d squared taken to the fourth. And we have to find the missing factor. First, take everything to the fifth power, so that's going to be 2 to the fifth is 32. C to the 15th, D to the 10th. And everything here to the fourth power, that'd be 16, C to the 8th, D to the 8th. So 16 goes into 32 twice. And we have 8 from 15, we need C to the 7th, and 8 from 10, D to the 2nd. So that's our missing factor. 44, 48 P to the 5th, Q to the 4th equals 2P Q squared times 4PQ times a missing factor. First, multiply these two factors together, so we get 8P to the 2nd, adding your exponents, Q to the 3rd. So now we can find out what we're missing. 8 goes into 48, 6. We have 2 from 5, we need P to the 3rd, and 3 from 4, a Q. So the missing factor is 6P cubed Q. And the last one of this type, 46, 75A to the 6B to the 5th equals AB cubed times 5A squared times something. So again, here we need to do the powers. So this is A cubed, B cubed, and this is 25A squared. So we need to multiply these two now, so we get 25A to the 5th, adding your exponents, since we're multiplying B to the 3rd. So 25 goes into 75, 3. 5 from 6, we need 1A. And 3 from 5 is 2, we need 2B. So it's 3AB squared. The next set of problems, we are to find the greatest common factor. So we have 36x squared, y squared, z squared, and 24xy squared, z cubed. So the 24 and the 36, the greatest common factor. This is 3 times 12, and this is 2 times 12, so it's 12. And they both have an x, and we choose the smallest power, so it's x to the first. They both have a y, and the smallest power is 2. They're both 2's. And z is in both, so we should put the z down, and the smallest power is to the second. So our answer is 12xy squared z squared. 50, we have 56 r to the 4th s cubed, 28 r cubed s squared, and 42 r cubed s. The greatest common factor of those three numbers, well, this is 7 times 8, this is 7 times 4, and this is 7 times 6. So 7 is definitely a greatest common factor, but each, the 8, the 4, and the 6 all have a 2 of them, so it's actually 14 is our greatest common factor. So we kind of did a partial factor tree, since each of these had a 2 in it. Now we check the variables. There's an r in all of them, and we choose the smallest power of the r, which is to the 3rd. And there's an s in all three factors, so s in the smallest power of the s is to the 1st. So it's 14 r cubed s. And the last one of this type, 52, we have 4p squared times p, the quantity p minus 1, and 6p times the quantity p plus 1 squared. The greatest common factor of 4 and 6 is 2. They both have p's, and so we can put a p down, and the smallest power of the p is to the first. P, the factor p minus 1 is not the same as the factor p plus 1, so we can't write that down. So our answer is 2p. And the last set of problems. We're going to simplify. We assume we're not dividing by 0 when I say the denominator equals 0. So we have w plus x quantity to the fourth over w plus x quantity to the fifth. You can treat these binomials as a single variable. So there are 4 x plus 6 x w plus x is on top and 5 on the bottom, so I can take out 4 here. 4 here, that leaves me 1 w plus x. So my answer is 1 over w plus x. And the last problem, 56, I have the quantity r minus s squared over r plus s and r minus s. I can take out 1 r minus s here, 1 here, leaving me an r minus s. So my answer is r minus s on top and r plus s on the bottom. And that concludes the evens. Be sure you check the odds as you do them and the answers in the back of the book.